A pleasant day to all of our viewers. I am Mr. Timothy Akana, and I am your online grade 8 mathematics teacher for today. Welcome to the final quarter of this school year. It is great to make it this far, and I hope that you learn a lot and will still learn more about mathematics from all of our FE lives. Now, for our today's lesson, you must be able to learn the following. First is to define and illustrate theorems on triangle inequalities, including exterior angle inequality theorem, triangle inequality theorem, and hinge theorem, with the MELC code M8GE-4A-1. Before we start our discussion for today, let us have a short activity entitled Compare Me. All you need to do is to use the correct inequality symbols to compare the following sides and angles of the given triangles. Are you ready? Let us start. So we have here triangle men. What inequality symbol are we going to use to compare for side ME and side EN? Very good. The correct answer is greater than, since the measurement of side ME is 12 and the measurement of side EN is 8. Let us have another one. We have here triangle saw. What inequality symbol are we going to use to compare the measurement of angle W and the measurement of angle A? That is correct. We are going to use less than, since the measurement of angle W is only 25 degrees, while the measurement of angle A is 70 degrees. And lastly, we have triangle tri. What inequality symbols are we going to use to compare the three sides of triangle tri? Wonderful! We are going to use less than. And if you will notice, the sides of triangle tri are listed from shortest to longest. Were you able to get all the correct answers? That is great. Before we proceed to our lesson, let us first define the trichotomy property. It says, for any two real numbers, A and B, exactly one of the following statements is true. We have A is less than B, A is equal to B, or A is greater than B. Let us have segment ME is equal to 3 centimeters and segment YU is equal to 5 centimeters. The length of segment SME is less than the length of segment YU. Or in symbols, we have ME is less than YU. Let us have another example of trichotomy property. We have angle D and angle G. Angle D is equal to 123 degrees and angle G is equal to 72 degrees. The measurement of angle D is greater than the measure of angle G. Or in symbols, we have measure of angle D is greater than measure of angle G. Now, let us discuss the different theorems on triangle inequality. Let us start with the exterior angle inequality theorem. The measure of an exterior angle of a triangle is greater than the measure of either its corresponding remote interior angles. In this given example, we have triangle PQR and angles 1, 2, 3. Angles 1, 2, 3 are called interior angles of triangle PQR. And angle 4, with respect to angle 3, is called the exterior angle. Angle 1 and angle 2, on the other hand, are also called the remote interior angles of angle 4. And by exterior angle inequality theorem, since angle 1 and angle 2 are remote interior angles of angle 4, then we can say that measure of angle 4 is greater than measure of angle 1, and measure of angle 4 is greater than measure of angle 2. Let us have another example. Let us complete the table by using the given figure. Let us first determine the remote interior angles of the exterior angle 4. What are the remote exterior angles if the exterior angle is angle 4? Very good. The remote interior angles are angle 2 and angle 3. And by applying the exterior angle inequality theorem, we have angle 4 is greater than angle 2 and angle 4 is greater than angle 3. Now let us determine the exterior angle if the given remote interior angles are angle 1 and angle 3. That is correct. The exterior angle is angle 5. And by exterior angle inequality theorem, we have angle 5 is greater than angle 1 and angle 5 is greater than angle 3. Next, we have the triangle inequality theorem number 1, which is all about the side-to-angle relationship. If two sides of a triangle are unequal, then the angles opposite them are unequal, and the larger angle is opposite the longer side. Now, given that in triangle art, side AR is equal to 6, and side AP is equal to 8. Write an inequality to compare angle R and angle P. Since the length of side AR is less than the length of side AP, then the opposite angles to side AR, which is angle P, is less than the opposite angle to side AP, which is angle R. In symbol, we have angle P is less than angle R. Now, let us try to name the largest and the smallest angle based on the given figure. Side NE is opposite to angle P, and side NT is opposite to angle E. Since the length of side NE is less than the length of side NT, then angle P is less than angle E, or in symbol, we have angle P is less than angle P. Therefore, the largest angle is angle E, and the smallest angle is angle P. Remember that in a triangle, the shortest side is opposite the smallest angle, and the longest side is opposite the largest angle, and vice versa. Let us proceed to the second theorem on triangle inequality, which is the angle to side relation. If two angles of a triangle are unequal, then the sides opposite them are unequal, and the longer the side is opposite the larger angle. Example, given in triangle PET, the measure of angle P is equal to 68 degrees, and the measure of angle E is equal to 52 degrees. Write an inequality to compare side EP and side PT. Since the measure of angle P is greater than the measure of angle E, then the opposite side to angle P, which is EP, is greater than the opposite side to angle E, which is side PT. In symbol, we have side EP is greater than side PT. Let us now try to list the sides from shortest to longest using the given figure. If you will notice, side AB is opposite the smallest angle, which is angle C, whose measurement is equal to 42 degrees. While side BC is opposite the largest angle, which is angle A, whose measure is equal to 71 degrees. Therefore, The sides of triangle ABC from shortest to longest are side AB, AC, and BC. Next, we have the triangle inequality theorem number 3. It says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. In symbol, let's have the sides of triangle ABC as A, B, and C. Thus, we have A plus B is greater than C, B plus C is greater than A, and A plus C is greater than B. Observe the table. We have triangle A, whose lengths of sides given in inches are 2, 3, and 4. Will it form a triangle? And to be able to answer this question, let us use the triangle inequality theorem. First, we have the sum of A plus B. 2 plus 3 is greater than the remaining side, which is 4. Next, we have A plus C. 2 plus 4 is greater than the remaining side, which is 3. And lastly, we have B plus C, which is 3 plus 4 is greater than the remaining side, which is 2. Since the sum of any two sides is greater than the remaining side, therefore, 2, 3, and 4 will form a triangle. How about if we change the value of C, of side C, to 5? Will it still form a triangle? Let us check. Applying the same concept, we have the sum of the first two sides, which is 2 plus 3, is not greater than 5. Next, we have 2 plus 5 is greater than the remaining side, which is 3. And lastly, we have 3 plus 5 is greater than the remaining side, which is 2. If you will notice, one of the two sides of the triangle is not greater than the remaining side because 2 plus 3 is equal to 5. Therefore, 2, 3, and 5 will not form a triangle. So again, let us try to apply the triangle inequality theorem number 3. Let us determine if the group of numbers below can be the lengths of the sides of a triangle. We have 5, 7, and 4. Let us check if the sum of the two sides is greater than the remaining sides. Are you ready? So we have 5 plus 7 is greater than 4. Next, we have 5 plus 4 is greater than 7. Lastly, we have 7 plus 4 is greater than 5. Since the sum of any two sides is greater than the remaining side, therefore, 5, 7, and 4 can form a triangle. How about 11, 3, and 7? Will this group of numbers can form a triangle? So we have 11 plus 3 is greater than 7. We have 11 plus 7 is greater than 3. And lastly, we have 7 plus 3 is not greater than 11. If you will notice, one of the sum of the two sides is less than the remaining side because 7 plus 3 is less than 11. Therefore, 11, 3, and 7 cannot form a triangle. Next is we have the hinge theorem. If two sides of one triangle are congruent to two sides of a second triangle, then the included angle of the first is larger than the included angle of the second. Then, the third side of the first triangle is longer than the third side of the second triangle. Let us have the given example. Given that two sides of triangle STR is congruent to two sides of triangle MUN, which are side ST is congruent to side MU, and side PR is congruent to side UN, as you can see on the figure, and the measurement of angle T, which is 98 degrees, is greater than the measurement of angle U, which is 83 degrees, then the side opposite angle T is longer than the side opposite to angle U. In symbol, we have side SR, which is opposite of angle T, is greater than side MN, which is opposite of angle U. Next, we have the converse of the hinge theorem. If two sides of one triangle are congruent to two sides of a second triangle, and the third side of the first is larger than the third side of the second, then the included angle of the first triangle is larger than the included angle of the second triangle. Let us refer to the given example. Since side AC is congruent to side XC, side BC is congruent to side YZ, and side XY is greater than side AB, since the measurement of side XY is 12 and the measurement of side AB is 8, then the angle opposite to side XY, which is angle Z, is larger than the angle opposite to side AB, which is angle C. Or in symbol, we have the measurement of angle Z is greater than the measurement of angle Z. Now, where can we apply these triangle inequality theorems in real-life situations? I have here an example wherein hinge theorem can be seen in real-life scenarios. Suppose you and your friend Mario, who is carrying a big box, is walking through your house and you have to go through your front door. You go first by opening the door so that the length of the opening is large enough for you to fit through. Mario goes in second and he needs to open the door a bit wider to make the length of the opening large enough for him to fit because he was carrying a big box. You will notice that when the length of the opening is shorter than the angle of the hinge, then the angle of the hinge is smaller than when the opening of the length is larger. You will also notice that the length of the door and the length of the wall remains the same in both cases when you and Mario entered. This has a great mathematical significance, and that there is a mathematical theorem that explains this scenario. And it is appropriately called hinge theorem. To be able to determine if you are able to understand the different theorems on triangle inequality, let us answer the following activities. For our first activity, state whether it is possible for a triangle to exist with sides of the given lengths. Press the heart react button if it is possible, and press the like react button if not. Are you ready? Let us start. First, we have sides 9, 9, and 10. Will 9, 9, and 10 form a triangle? So using the triangle inequality theorem number 3, which says that the sum of two sides of a triangle must be greater than the remaining side, we have 9 plus 9 is greater than 10, 9 plus 10 is greater than 9, and again 9 plus 10 is greater than 9. Since the sum of any two sides is greater than the remaining side, therefore 9, 9, and 10 are possible lengths of a triangle. Next, we have 2, 3, and 7. Applying the same concept, we're going to add the two sides of the given triangle and determine if it is greater than the remaining side. So first, we have 2 plus 3 is not greater than 7. Next, we have 2 plus 7 is greater than 3. And lastly, we have 3 plus 7 is greater than 2. If you will notice, one of the sum of the two sides is less than the remaining side, because 2 plus 3 is less than 7. Therefore, 2, 3, and 7 are not possible lengths of a triangle. Lastly, we have sides of the triangle which are 8, 8, and 8. Will these lengths form a triangle? Since all the sides are equal in length, we can just have one set of sum to verify the theorem. So we have 8 plus 8 is greater than 8. Therefore, 8 and 8 are possible lengths of a triangle. For our next activity, can you name the largest and the smallest angle based on the given figure? So we have here triangle BOK with side BO is equal to 3. Side OK is equal to 5 and side BK is equal to 4. If you can still remember, the largest angle is opposite the longest side and the smallest angle is opposite the shortest side. Therefore, the largest angle is angle B since it is opposite the longest side, which is side OK, and the smallest angle is angle K since it is opposite the shortest side, which is side BO. Now, using the given figure, list the sides of triangle GQB from shortest to longest. In triangle GQB, angle G is equal to 62 degrees. Angle Q is equal to 54 degrees. And angle B is equal to 64 degrees. The side opposite to the smallest angle, which is angle Q, is side GB. And the side opposite to the largest angle is side GQ. Therefore, the sides of triangle GQB from shortest to longest are side GB, side QB, and side GQ. For our next activity, you are going to fill in the blank with is less than or is greater than symbols. We have here triangle 1 and triangle 6. Based on the given, if you will notice, the two sides of triangle 1 are congruent to the two sides of triangle 6. And the measure of angle E is 90 degrees, which is less than the measure of angle S, which is 93 degrees. So what do you think is the correct inequality symbol for the statement side ON blank side XI? Very good. The correct answer is less than. Since side ON is opposite side, because side ON is opposite angle E and side XI is opposite angle S. Now let us have triangle ABC and triangle XYZ. What inequality symbol are we going to use to compare the measurement of angle B to the measurement of angle Y? That is correct. We are going to use is less than. Why? Because if you will notice, angle B is opposite the shorter side, which is side AC, and angle Y is opposite the longer side, which is side XZ. Therefore, the measurement of angle B is less than the measurement of angle Y. So before we proceed to some more activities, always remember that in exterior angle inequality theorem, the measure of an exterior angle of a triangle is greater than the measure of either its corresponding remote interior angles. In triangle inequality theorem number 1, which is about the side to angle relationship, it states that if two sides of a triangle are unequal, then the angles opposite them are unequal and the larger angle is opposite the longer side. Triangle inequality theorem number 2, which is about the angle to side relationship, it states that if two angles of a triangle are unequal, then the sides opposite them are unequal and the longer side is opposite the larger angle. And in triangle inequality theorem number 3, it says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. And lastly, we have the hinge theorem, wherein if two sides of one triangle are congruent to two sides of a second triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. I hope you were able to understand the different theorems on triangle inequality. Now let us proceed to the question and answer portion of this FB Live. Kindly type in your question in the comment section. So, we have here an interesting question. Sir, meron po bang ibang triangle inequality theorems bukod sa mga na-discuss nyo? Thank you for that wonderful question. And the answer is yes. May mga triangle inequality theorems pa tayo na ginagamit to determine if the given side lengths of a triangle will form an acute triangle, obtuse triangle, or right triangle. So we have here another question. Okay, so thank you for that wonderful questions. If I was not able to address some of your questions, you may just refer it to your subject teacher during your follow-up discussion. And for your homework, kindly answer page 6 of your alternative delivery mode, or ADM, and submit it to your subject teacher. Thank you and have a blessed day.